So the first one here, did you guys need to turn the lights off? Somebody go grab the lights then for us. That'd be great. It's going to be a game of chicken here to see who's going to do it. Thanks, Sydney. So it says a plane can travel 525 miles per hour under its own power. If a pilot flies at the plane's maximum speed at 125-degree bearing, and there's a 35 mile per hour wind traveling at a 200-degree bearing, what is the plane's actual speed and bearing? So notice that this problem is very much like the bearing problems we've done before. We're going to break this into two pieces. But notice in this problem we're asking for speed and bearing rather than the distance traveled in bearing. So we don't need any how long the plane was going, this and that, to do this problem. So I'm going to start by just resolving each of these two forces into components. So the first one, we have 125-degree bearing, so I've gone from the north 90 degrees and then like 35 more. So I now need to figure out my standard position angle. So doing that, I have 90, 90, 90, and then the complement of 35 is 55. So 90 plus 90 plus 90 plus 55 is 325. And then using that, I can calculate my horizontal and vertical components. So my horizontal component is going to be the speed of the plane times cosine of 325. And my vertical component is going to be the speed of the plane times sine of 325. I'm going to do the same thing now for the wind. So the wind has a 200-degree bearing, so 90, and 90 is 180, and then like 20 more is 200. And the angle that I'm really interested in, though, is this standard position angle. So 90, 90, and the complement of 20, which is 70. So that tells me that that angle is 250 degrees. So the horizontal component is going to be 35. The wind speed times cosine of 250. And the vertical component is 35 sine 250. And to get my final position then, I just add up the x components and add up the y components. To get a kind of final position. So that I'm going to use the calculator to do. Yeah, what's up, sir? Sure. about now? Is that better? You caught up? So it's calculator time. I'm going to do 525 cosine 325 plus 35 cosine 250. But before I type this in, let's just check our mode real quick. I am in degree mode, so that should be good. Close one. And then I'll do the same thing except with sine. So 525 sine 325 plus 35 sine 250. And that's going to give us negative 334. So we have 418.08, comma, negative 334.02. Now that I've calculated a final position for my plane, I'm going to go ahead and draw myself a picture of kind of where that's at. So I'm going to go 400 over and then 300 down. So my plane is kind of going in that direction. Everybody's okay with that? To calculate the speed, I'm just going to do the Pythagorean theorem. So I'm going to take the final x position and the final y position, square them both, add them together, and square root them. So I'll just do that on my calculator real quick. Note when I'm doing this, though, I'm going to put a parenthesis around the negative one, just so that I make sure it does the squaring right. So that total speed then, or final speed, is going to be 535.13. Okay there? And now the bearing is really what I'm going to be using this picture for. So the bearing is that, right? We're going from true north and rotating clockwise. So it's going to be 90 plus something, right, to get that bearing. Now, I can't calculate that something part directly, but what I can calculate directly is my standard position angle. I'm going to call that guy just theta F. So that standard position angle is going to be tan inverse of y over x so when I go and I type this into my calculator, it gives me negative 38.62. So what this is describing is this angle here, right? Well, it turns out I don't even really need to calculate the standard position angle with a positive angle measure. That 38.62 is going to be that question mark. So my bearing then is just 90 plus 38.62. And because it's 9:28 in the morning and my brain isn't moving at light speed, I'm going to use the calculator to kind of do that for me. But I'm going to get 128.62 degrees. So there's my speed, and there's my bearing. by, girls, if you want to take one of these worksheets on your way out, that would be good. There's one each. Thanks. Have fun at your band stuff. Megs? Well, when we calculate a bearing, when we're going clockwise, it's a positive angle measure, which is why when I converted this into a bearing description, I lose the negative. There are no negative angles for bearings. So, because it's going the correct direction, I don't really even need to worry about it. Does that make sense? So, that's kind of why I threw out the negative is, yeah, essentially when you go to bearings, everything is positive, regardless, because we're only going one direction, so negatives are meaningless. Okay with that? Good question. Let's look at the next one. We're just going to look at these two examples here today, and then we'll spend the rest of our time in class just kind of working on some stuff. Yeah, of course. So this problem's a little bit different. So it says here a plane can travel at 480 miles per hour under its own power. The pilot sets a bearing of 320 degrees. As the plane travels, the pilot notes that the plane is actually traveling at a bearing of 325 degrees and at 472 miles per hour. What is the bearing and direction of the wind? So what we know is that we have the plane plus wind is going to give us the final. Everybody's okay with that idea? That's basically what we did in the previous problem, right? In this problem, though, we're looking for the wind. So what can we say that the wind is going to equal? A plane. So what we're going to say here is that like xw, yw is going to equal xf minus xp, comma yf minus yp. So instead of adding our two components, like we had done in the previous problem, here we're going to be subtracting. And remember that subtraction is not commutative, so we have to make sure that we're subtracting in the correct order here, that we're doing final minus plane. Everybody okay with that reasoning? Okay. So our final says we have a bearing of 325 and a speed of 472. So a bearing starts at true north, and we've gone 90, and then 180, and then 270, and then like 55 more to put us over here at 325. And I'm not interested in the bearing angle so much as I am the standard position angle, which is 90, and then the complement of 55 is 35. So I can say my theta final is going to be 125 degrees. So x final is going to be 472 cosine 125. And y final is going to equal 472 sine 125. And maybe we'll label this final. And this will be the plane. So the plane says we've set up bearing of 320 degrees at 480 miles an hour. So 320 is 90, 180, 270, and then 50 more. And again, we're not so interested in the bearing or in that standard position angle, which is 90. And then the complement of 50 is 40. So our theta plane is going to be 130 degrees. So our x-plane is going to be 480 cosine 130. Our y-plane will be 480 sine 130. And now to get our wind, that's going to be xf minus xp and yf minus yp. And to do that, it's calculator time. Oops. 80 cosine 130. 472 sine 125 minus 480 sine 120. Oops, not 125, 130. So our wind is 37.18, comma 18.94. We just now need to resolve that into a speed and bearing. So if I go 37 over and 18 up, we're like somewhere over here. So my wind speed is going to be the x from the wind squared plus the y from the wind squared, all square rooted. To do that, I'll just use my calculator. That gives me 42.29. miles per hour. So there's my wind speed. And then I'm interested in the bearing, but I can't calculate the bearing directly, but I can calculate that standard position angle directly. And if we look at the relationship here, obviously the bearing is going to be the complement. So that standard position angle we can take by doing tan inverse of the y-coordinate of the wind over the x-coordinate for the wind. So tan inverse y over x which is 26.61. So in this case, our bearing is going to be 90 minus that. Obviously, just the complement. We can see that easily from our picture. So 63.39. Any questions, Anjali? Sure.